Hello everyone and welcome to today's talk about Active Directory LDAP. In today's talk, I'm going to present to you everything I wanted to know about Active Directory LDAP when I first started learning it. My name is Remy Gascou and I'm also known as Podarius. I am an offensive security consultant and regional pentest team leader at Capgemini in Toulouse, France, and I'm working mostly in pentesting and exploiting new vulnerabilities. You can find a few links here to most of my works, that is open source tools to exploit vulnerabilities, pentesting tools, research articles on new techniques, and of course CVEs. So first of all, I'm going to present a bit of context to this talk. We are going to focus in Windows networks, and more specifically in a Windows internal network of a company, a typical Windows network. You would have a domain with many machines attached to the domain and many computers, workstations, servers, printers, phones, whatever you want. And in this domain, you will have two servers known as the domain controllers, DC1 and DC2. And these are what we are going to focus on later on. So if we focus on DC1 and DC2, the domain controllers in a Windows domain will have a lot of services open. We are talking about tens of network protocols, and most of them are used in specific cases, in authentication, in services. They can be used in many ways. And in today's talk, we are going to focus on LDAP, which is one particular network protocol of the domain controllers. It's not specific to Windows domains. It can be used in other types of network architecture. LDAP is not specific to Windows, but we are going to focus on the LDAP of Active Directory and the link between LDAP and Active Directory. First of all, we are going to deep dive into the LDAP structure and its objects. Afterwards, we are going to see what is the scope of an LDAP query and how we can make them. Then we are going to deep dive into LDAP naming contexts. And finally, we are going to see two things that can be useful to engagements. The first one is a few cool tools you can use with Active Directory LDAP in offensive pentesting. And the second one is a way to common vulnerabilities that we can find in Windows domains using LDAP. So the first thing to know about the LDAP structure is that it's a tree. So basically you have lots of objects organized in various leaves and in various branches that are distinguished by their names, their groups, and you will have lots of objects stored inside this structure. The second thing to note about LDAP is that the root object is the domain name. So here DC equals lab, DC equals local means we are in the domain lab.local. So the LDAP objects that I mentioned earlier, they have many properties and values. And one of the most important properties of LDAP objects is their distinguished name. It's basically where we can find them inside the LDAP. It's the path inside the tree of where you can find them. Also, as we are inside an Active Directory domain, all LDAP attributes have an unique identifier called object GUID, which identifies uniquely each object inside the LDAP inside the Active Directory. So the object is stored in LDAP and linked to Active Directory by this kind of values. And finally, all of these objects contains attributes which have values, and they store the actual data we are going to store inside the objects. So here is an example of what it looks like. For the object user1 inside my LDAP, we have a description, a distinguished name, given name, user SN created, name, we have user account control also. We have many properties that are specified to this object because it's a user. We have user account control, we have bad password count, for example. We have many properties that we can store inside the LDAP object of this user, which is specific to user1. So now we have seen what is an LDAP object, and we are going to need to query them in order to get specific attributes of the whole content of an object. And we are going to see this in the next slide. So how to make an LDAP query? Basically, you need three things. You need the base object. It's the distinguished name to the object on which you are going to make the query. For example, user1. you need a query, which is in LDAP syntax. You will select the attributes you want. For example, here I'm selecting all objects with object class being user and with ADM in their names. So for example, when you are doing an internal pen test, it can be quite useful to do this kind of queries to list all the administrators of a Windows domain, for example. And the third thing of an LDAP query is the attributes to retrieve. For example, name, user account control, description, or the wildcard. If you put just the character star, it will retrieve all the attributes of the object. It's very important because this field attributes allows to select specific attributes of objects and, for example, narrow down the query to only the attributes you need and not being spammed with a lot of values that you really don't need. So for example, here, if I do a query with all these elements, we are going to get in return only this. So we are going to only have the specific attributes we ask for. So name, user account control, description, and their values. So user 1, 512, and my password is weak. But now it would be interesting to know what if we wanted to list all users, for example, or what if we wanted to make specific queries on a lot of objects in the same time. How can we do this? We can do this with scope queries. It's 3 flags you have to put inside the query to specify on which object you are going to perform the search. So there is 3 flags to the scope of queries: base, level, and subtree. The first one, base, is only performing the search on the specified object. So if you are putting in the object other thing, it will only search on the attributes of this object, this specific object. The second one, level, it's going to perform the search on every object in the same depth in the tree as the given object. So if you put in other thing, it will also query the attributes of the object something. And you can select attributes on all the objects as in the same level in the tree. And the last one is subtree, is going to select all the objects underneath the selected base object, excluding the base object itself. So you are selecting, for example, CN equals to users, and you are going to select every user inside the subtree of CN equal to users. This is often what we want to use in offensive pen testing, as we are going to need to select as many objects as we can in order to perform a query and find specific rights, specific attributes on many objects. We are not going to iterate object by object to perform a base level query, for example. For example, in pen testing tools, it's often used as a subtree query because we really don't need to iterate over all the objects of the LDAP. We only need to select one, which is our base object, and then perform our LDAP query in order to select all the attributes of these sub objects inside the tree. So now that we know how to perform a query, I'm going to present to you a little challenge. How would you extract all the information from the LDAP in a way you want to perform a backup of the LDAP to have locally all the information into a passable format, for example, a JSON, a database, or whatever you want. But how would you do to extract all the information from this LDAP? The first thing we can think about is to perform a query with object class equals to store, which is a wildcard matching every type of object. And we are going to select every attribute, so a wildcard too. So if we are doing this query in a subtree starting from the root object of the domain, the DC equals lab, DC equals local, we are going to select all the objects, and therefore we are going to dump everything from the LDAP, right? Well, let's try it. So if we try to select everything with object class equals to wildcard, we are going to select every sub object in the tree, and we are going to dump it to JSON, for example. And as we can see, it returns 14 objects, and in many different groups, in many different categories, but we have 14 objects. And when I was doing this, I noticed that some values that I wanted were not in these 14 objects. So I started to mess around with LDAP queries, and I made an LDAP query not on the root object of the domain, not on DC equals lab, DC equals local, but on CN equals to configuration, DC equals lab, and DC equals local. And I had 1,600 objects, which is way higher than 14. So something is quite going on here. In LDAP, you have something called naming context or partitions. These partitions are part of the tree structure and they are independent from each other, which means if we want to extract objects from these trees, we need to perform queries on the root object of this naming context. For example, in this graph, you see DC equals lab, DC equals local, CN equals to something. We need to perform a query on CN equals to something if we want to have anything with thing1 and thing2. On the other hand, if we are going to perform a query on DC equals lab, DC equals local on the root object of the LDAP, we will not have any object from CN equals to something, and thing1 and thing2 will be invisible to us. So I've put here the three types of partitions that we can find into the Active Directory LDAP. Basically, these are the partitions that are enabled by default. You can add new ones, and in forests, meaning in groups of domains, you can have multiple partitions. There is two very interesting partitions. The configuration partition, which holds lots of information about the domain, the forest, and it will be replicated in every domain controller. And the domain partition, which holds the Active Directory objects, such as users, computers, every object that we saw beforehand. The second one is the domain partition, which will hold the Active Directory objects of the domain that we are currently in, such as users, computers, everything that will be associated to the local domain, for example, lab.local. If we are in a forest with multiple subdomains, each subdomain will have its own domain partition with its own objects in it. It will not be replicated on other domains. So now I'm going to present to you a few tools you can use in your Active Directory LDAP engagements. The first one is LDAP Monitor, which allows to monitor creation, deletion, and any changes in LDAP objects live during a pentest, system administration, or whatever you want. Basically, it's a way for an attacker to see what's happening inside the domain in live mode. The second one is PyLAPS and SharpLAPS. These two tools are used to read the attributes set by the local administrator password solution from Microsoft from the LDAP directly. You need to have rights to read these attributes, but you can extract them with these tools. So the first one I want to talk about is LDAP Monitor. So a few months ago, I was working on a project called LDAP Console, which is basically a way to perform queries into the Active Directory LDAP from a Linux machine using Impacket. And as I was working on the LDAP console, I added a few functionalities such as query objects, predefined queries, so we don't have to remember how to list every user that is Kerberos table, for example. As I was working on this, I thought it would be cool to have a kind of way to make a difference between two queries. For example, select every user and type diff to see what is the difference between the two responses from the LDAP. So I implemented it, and then I thought, what if we did this on every object of the LDAP using an object class equal to wildcard every second, for example. If we are querying every LDAP object every second and then performing a difference between the two responses, we will literally have everything that changed inside the LDAP, the attributes, the new objects, the deleted objects. We would basically have logs of everything happening inside the LDAP. And that's how LDAP Monitor was born. So LDAP Monitor is written in Python using Impacket, and so it can be used from Linux machines. As we can see here, it's very simple to connect to a domain using LDAP Monitor. You just have a few things to enter and you are basically connected to the LDAP and starting doing live differences every second. Here I've been connecting as an administrator, but it's really not necessary. With a normal user, you can see almost everything in the LDAP. Only a few things will be disabled, so you cannot see them. But if you are administrator, you will see many more things. For example, the replication of the domain controllers, new DNS configurations, everything that is in the configuration database. You will see many more things. So it's interesting to use it as a domain administrator when you are trying to learn what is happening inside your own domain. So here it's a little demonstration. When you are starting LDAP Monitor, you will see a listening for LDAP changes, and then after a few moments, if something changes in the LDAP, you will see it in the logs directly with the timestamp. Here we can see that a new user was created, so LDAP Monitor will not bother you with every attribute of this user because it will dump the whole object and it would be extremely verbose. So it will just say that this user was created. But then when something is modified inside the LDAP attributes, you will see everything that changed inside this object. For example, for user 2, here we can see it changed its delivery office and it changed from woo to first floor. So as this attribute was changed, LDAP Monitor will print the old value as well as the new value, so you can see what it changed to and from. The same thing happened for all the attributes of these objects. So for example, if we change the description, it will also appear inside LDAP Monitor. So here is a few cases where LDAP Monitor can be useful. The first one is to detect account lockout in real time. For example, if you are doing a pen test, you want to monitor whenever you are doing brute forcing to see if you are not locking out accounts. And LDAP Monitor can help you with this because if you are locking a user, you will have the new attributes bad password time and lockout time, which will be added, and you will see lockout time set to when the account is locked out. You can also use it to check if your privilege escalation worked fine. For example, when you are using NTLM relays with escalate user option, escalate user option is an option that allows to control an account. For example, you have already an account inside the Active Directory and you want to change the rights on this account if you are able to relay user with more rights on your account. You will set NTLM relays escalate user option so that the user you control will have more rights after the relaying of a domain admin, for example. It can be useful to escalate your user to domain admin rights without taking over a real domain admin. And the third case is detect when users are logging in to know when you can start a network poisoning with responder, for example. If you are connecting inside the LDAP and you are seeing a lot of user logins, it can be the moment where the users are logging in for the first time in the day. So you want to start a network poisoning, so you can relay, maybe you can relay authentications, maybe you can poison some of the Windows machines, so it will go through your responder afterwards. So if you are seeing a lot of logon events inside the LDAP monitor, it might be time to start a network poisoning. So another cool tool to use with LDAP, before deep diving into this tool, I want to talk to you about really common vulnerabilities that we can find in many Windows domains. In many Windows domains, we see that most of the local administrator of all the machines have the same password or the same NT-hash, depending on whether or not it's a real password or just a random string. And if an attacker has control of at least one machine inside the network, it means that if he can retrieve the NT-hash of the local administrator of one machine, he can connect as administrator on all the machines of the network that are using the same password for the local administrator account. So this is a huge vulnerability because if any of your machine is compromised, most of your machines will be. So it's a real big problem, but fortunately there is a solution called the LAPS for local administrator password solution, which allows to set random passwords for the local administrators of all the machines. And these passwords will be changed, for example, every week and they will be stored inside the LDAP in a specific attribute called MS-MCS-ADM password of the LDAP object. Of course, this attribute is not public. You need to be domain administrator to see these attributes, or else any user could have access to any machine, and it would be a huge problem. So here is two tools to retrieve LAPS passwords from a Windows domain. The first one is PyLAPS. It's a tool I wrote to be able to retrieve LAPS password from a Linux machine to a Windows domain. For example, I do most of my pen testing from Linux machines, so I like to have tools that work on Linux. This one is in full Python and uses Impacket to connect to the LDAP and retrieves the LAPS passwords of all the local administrator of all the machines. And the second one is Sharp LAPS from SwissKey, which can run standalone in a Windows machine as an executable, or from a Cobalt Stack beacon with execute assembly. On my PyLAPS, as you can see, it's the same syntax as LDAP monitor. It's fairly easy to use, and it will extract every LAPS passwords from all the computers that have LAPS activated in their LDAP object. To read these attributes, you need to have specific rights, meaning generic read, for example, on the target object, or you need to be domain administrator of all the domain. To read these attributes, you need to have specific rights on the target object, or you need to be domain admin, because they are highly sensitive attributes, so they cannot be read by anyone. And lastly, I want to show you a way to common vulnerabilities that I find often in my pen tests. This vulnerability is due to a lack of understanding of what is public and what is not inside LDAP. If there is one thing you need to remember about LDAP from an offensive and defensive point of view, is that most attributes present in LDAP are readable by all authenticated users without specific rights. Not all the attributes can be readable. As we can see, the LAPS passwords cannot be read by any user, but most of the attributes are readable. This means you need to never store private information into LDAP, especially in public fields such as the description fields of a user, because it's something that we can see really often. Passwords in description of users. You can create a user and put a password in description because you are doing some test on this account, and then you forget that you have put the password inside the description. But as we can see, any authenticated user inside the domain can query all the other users, and you will see the description even if you are not domain admin. Therefore, any user that will query the description of all the other users can potentially take over other accounts because there is their password in description. So please be careful and remember that all the attributes in LDAP should be treated as public and do not store private information in it. Thank you for listening. I hope this talk was interesting. And if you want to check out my other works, you can find them on GitHub, on Twitter, or on my website.